Hello everyone, welcome to today's video. In today's video we're going to create random sample data from a distribution, and we're going to use SPSS to create those random samples, and then we'll use that just to illustrate this concept of a central limit theorem. So what we want to do is, I just want to open up to SPSS. Give me a second. So what I've got here is I've actually got the data set, and this is going to be the same example that we used in the Excel movie 2 using Excel to create the same problem. So what we have to do is, if this was a blank, then what we need to do is we need to set the ID first. So what we need to do is I want to create 10 samples, and each sample has 1,000 numbers in. Okay, so what I've done is to create an ID. Now, unfortunately, you can't do this easily in SPSS, but what you can do, if you go to Excel, put a starter number in there, and then click on Fill, Series, and we want columns, and we want numbers 1 to 1,000. Okay, and then what we can do then is we can then copy those numbers, copy, and then go to SPSS, and then paste them in there. So I'll just paste them in. Okay, right, and then once I've done that, then I can create these samples. So the question is, how do we create these samples? So I've generated 10 samples here, and each sample has 1,000 numbers in. And each of those numbers is being randomly selected from a normal distribution. Remember, the population mean was 45,000, and the population standard deviation was 1,000. So we use transform compute variable. So you can see I've got all the values here, but if I just go x1 there, I can overwrite that version. And then in here, I need to put the numerical expression. So I want the random number generator. So we scroll down the list, there we are, random numbers. And I want normal. So I just scroll down and find normal. There we are. There's normal. Okay, double click. Now, you'll notice here that the first question mark is the population mean. Just like for the Excel example, we're using 45,000, and the population standard deviation was 1,000. Okay, so once I click, now because I'm doing this, this number here will be a random number generated from this normal distribution where the population mean is 45,000, the population standard deviation is 1,000. But because I've got 1,000 cases, it will do this 1,000 times. So I click OK. It'll ask, do you want to overwrite the existing variable? Just say yes. Okay. Now in the output file, it'll tell you exactly what you've done. So if I now go back to the data file, I can do exactly the same for x2, x3, x4, x5, x6, x7, x8, x9, x10. So let's do x10, shall we? So transform compute variable. So in there we put x10. Then all I've got to do is click OK and overwrite the existing data. Let's go back to the data file now. So x1's been newly generated. X10 has been generated, and then what we do then is we want to calculate these sample means from x1, x2, x3, x4, x5, x6, x7, x8, x9 and x10 to calculate that sample mean, and we do it for every single sample case, and we have 1,000 of them, which gives us 1,000 sample means. And to do that, all we need to do is create a U variable, so transform compute variable. This time we call it x bar, and I already have it there, remember. Now let's make sure I get the right uppercase. So it's x lowercase bar. Okay, and in here, what I want to do then is I want to type in mean, right? And then I want to go x1, x2, x3, x4, x5, x6, x7, x8, x9, x10. Then close bracket. Okay, and then if I click OK now, it'll calculate all these means for each case. So what we have there is a set of sample means. So it tells you in the output file what you've done. Let's go back to the data. Okay. And then once we've done that, then what we can do then is we can then use the sample mean values, X bars, there's 1,000 of them, and we can then do some analysis. So let's go to analyze descriptive stats. Let's go to frequencies. Let's go to statistics. Okay, so we want the mean value. So that will give us the mean of the sample means. Yeah. And we also might want the standard deviation. And that will be the sampling error of the sample means, or the standard deviation of the sample means. And then we can click continue. Now, if we go on charts, we can ask for an histogram, and we can also fit a normal curve to that histogram if we believe that the population data was correct. So we can fit the curve to that histogram. Click OK. Okay, and what we need to do, of course, is make sure we transfer the variable into the variables box. So we click OK now. And if I maximize this after a few seconds, so what it's saying is the mean of the sample means is 45,007. Well, we randomly selected with a population mean of 45,000. That's the standard error of the sample means. We remember, which is sigma divided by root n. So 1,000 divided by etc. you will get 346. Now we scroll down. So there's a frequency, because I forgot to switch off frequencies. Okay, if I scroll down, and then after a few seconds, there's our histogram. So the blue bars are the histogram. You can see it's approximately normally distributed, which is what you would expect. Okay, so that's how you use SPSS to generate a sample of a particular size. And if you want to do more samples, so in our case we did 10, it's quite straightforward. Okay, so that's it for today. Bye for now.